So once again, a very good evening to all of you. It's really an honor to be with all of you. My name is Arvind Kumar. I'm the head of pre-construction services at Hydro Building Systems Middle East. I have my colleague also available on this call, Mr. Khalid. He's our pre-sales manager. And first of all, a big thank you to ArchiNet for organizing this and putting this together. I've been told that we have more than 600 people registered in for this event. So it's fantastic that at such a late time in the evening, you've taken out your weekend time and come to attend this session. Today, the agenda is very simple. We would first introduce this whole week. What are we planning to do? And I think this is quite interesting to know the topics which we have planned and scheduled for this whole week. I would also give you a quick rundown about what Technal does. And today's main agenda, of course, is the key functional parameters while choosing windows, doors, and facade. And then we'll wrap up today with a Q&A session. So when we were talking with Mr. Mohammed and on the different topics which we had, and we were quite confused to choose which topic would be appropriate, and Mr. Mohammed proposed, hey, why not we do the whole session in the whole week, because this facade topic deserves the whole week, because we need to cover so many topics. Therefore, we have put together what I feel is something very interesting for this whole week. We start today just the basics to start with. What are the important functional parameters which one should pay attention to while choosing windows, doors, and facade. Tomorrow we will go down to the basics, which is the fundamentals of curtain walling, because this is a very important topic, especially for growing markets such as Saudi Arabia. On Monday, we will talk a little bit about the new upcoming trends in windows, doors, and facade. What are the new things which architects and designers can look forward to? We are in 2020, and we want to know what are the latest trends and technologies which are available in this wonderful industry. On Tuesday will be a very important topic on fire and life safety. This, I think, is very critical, especially having heard so many incidents of fire, and recently a very unfortunate event happened in Beirut as well, of the bomb blast. So we are going to cover a lot of interesting topics on how to enhance your facade when it comes to fire and life safety. That's on Tuesday. On Wednesday, we have another interesting topic, which is focusing and revolving around technology. So we're going to talk about BIM solutions for facades, for windows, doors, and facades. So I think that's also quite an interesting topic as well. And to culminate the facade week, we're going to talk about sustainability. We're going to talk about energy efficiency. We're going to talk about circular economy, how as architects and designers, we have a huge opportunity and responsibility to design sustainable and energy efficient facades for the generations to come. So this is a quick rundown for the entire week. And without further ado, I would like to start off today's session by giving you a quick introduction of who Technal is. So Technal belongs to the Hydro Group. So Hydro is one of the world's largest global complete aluminum company, which is having more than 114 years of experience in the business of aluminum. As Hydro, we are probably one of the only companies who has a complete value chain. So we start off with bauxite and alumina. We have our own bauxite mines. We produce hydroelectric power, and that's why the name Hydro comes. And we use this clean source of energy to convert bauxite to primary metal. We produce billets, rolling sheets, ingots, and from here we also produce extrusion. So we have 5 business units, and as Technal, we come under the extrusion business unit. So in the extrusion business unit, apart from having more than 100 locations of extrusion facilities globally, we also have precision tubing, which is indirect aluminum production, which is used in radiators, which is used in refrigerators, industrial applications, and of course we use in building systems as well. So you would find Hydro products in brands like Tesla, in Coca-Cola, in cans. So you find our brands, our products used in a very wide range range of multiple brands. Now, coming to the architectural business, the building systems, we have with us 4 brands under the Hydro Building Systems. We have the Kona, which is a German brand, which has more than 70 years of experience. We have Technal, which is a French brand. We have more than 60 years of experience. Domal, an Italian brand, and Sapa, which is a Scandinavian brand. All of this put together, we have a wide variety of products and solutions which we offer for the windows, doors, and facade business. The Technal brand is the most popular brand in the Middle East because it's been here for more than 40 years in the Middle East and has got some really rich experience dealing with local conditions, local environment. As a brand, Technal hails from France, from the southern city of Toulouse, which is also very famous for the Airbus. And Airbus is also manufactured in the same place where Technal is also originating from. And Technal as a brand is more than 70 countries. We have 60 years of experience. And architects really like to work with Technal because we tend to work with them very closely in helping them to design and achieve their design intent for the wonderful architectural pieces they have. In terms of product solutions, we have sliding systems, windows, doors, facades, and we also have fire-rated windows, doors, and facade. We have bullet and burglar-resistant products. We have handrails and pergolas and conservatories. And you will start seeing these products in various formats along this week as we showcase to you different technologies and new trends. What's very significantly important about Technal is that all our products are tried and tested at our Innovation and Test Center in Toulouse for 3 years. So even before a product comes to the market, we are doing a lot of testing, we're doing a lot of market prototyping before it's finally launched and arriving at the marketplace, which gives you a sense of peace of mind for anyone working with Technal because all these products are tried and tested. We also have in the lab a wonderful facility for acoustics, seismic studies, structural studies, joinery enhancements. Also, we have a dedicated team who's studying on net zero and doing a lot of research and development around net zero buildings. So if you as an architect or a designer would like to explore or further do research and development, please feel free to talk to us. We'd be more than happy to collaborate with you and encourage and work with you and support you in your R&D for your projects. In a nutshell, Technal has been here for 40 years in the Middle East. We serve over 10 countries, over more than 150 authorized installers across GCC. We have accomplished and completed more than 2,500 projects. We have a 95-member team in the Middle East, which is probably the largest in the Middle East for a building facade system company. And we have 3 warehouses, which is having more than 60,000 square feet of space. So our headquarters for the whole operations is in Bahrain, in Manama, and that's a small, nice photo of our office complex. And we have a couple of warehouses in Bahrain, in Dubai, and in Oman as well. You see some photos of our office and our showroom. If you ever pass by Bahrain or Dubai, please let us know. We would love to host you in our showroom. And that's our wonderful team here in Dubai, and they're all looking forward and excited to welcome you whenever you pass by this side. So what do we do in the region? So apart from Technal being a global leader and a local leader in profiles and accessories, we also do a lot of other stuff: training, testing, project services, which is something that I want to talk to you again soon, software, consulting, optimization of products, testing, and certification. So we have a whole range of solutions which we offer to this region. In terms of project service, we work with architects right from the concept stage, where when the architect starts to design a product, we are there with them trying to support and help them in achieving their goals. And as the project moves to the detailed design stage, we're giving further inputs, further clearer details with interfaces so that the architect can develop very good, strong IFC drawings so that the contractor doesn't take things for granted and starts to working with really high quality solutions and good recommended finishes as per the design intent of the architect. Once the project moves to the tender stage, this is where we have a new term which we all keep hearing, value engineering. And this is something where we also work with the architects, try to help them and understand ways and methodologies to help them better the proposal and help hopefully achieve the desired cost targets for the project. And last but not the least, once the project is under construction, construction. We have a dedicated team of site engineers who visit you and help your resident engineers to ensure that the products which were designed in the concept stage and detail stage are used completely in the right fashion at the particular project site. And this is where we also help architects to ensure, and we ask them also to make sure that Technal reviews and stamps the shop drawings so there's no mistake and error which could happen at the project level. So in terms of projects which Technal has done, we work across all kind of verticals, all kind of formats of projects, from education to villas to tourism-related hotel projects, health and well-being, offices and shop fronts, private and residential. So it may be a small project to a super tall, super structure, high-rise building. We work across all formats. Some of the projects which I'm proud of to talk about in Saudi Arabia, this is King's Road Tower, which is quite famous, also known as Jeddah Tower, because it hosts one of the world's largest LED screen. It's got about 10,000 square meters of LED screen on the facade. It's another nice project in Riyadh, the Burj Ramla Towers, uber luxury project where we've used some very interesting solutions. This is the Stars Avenue Mall in Jeddah, also a very interesting project because today this is also hosting a fantastic, really wide curved LED screen right on the facade, and it attracts so many different eyeballs as you enter Jeddah from the airport. And this is a very unique project in Jeddah also, which is King Abdullah Specialized Children's Hospital, which is again having a very interesting double skin unitized facade, which is also done by Technal. And not to forget the past, this was one of the first curtain wall projects in Saudi Arabia and Jeddah, the Bridgestone office, which was done in 1983 and still remains an iconic landmark for people who are living in Jeddah. And of course, if you pass by the holy city of Mecca, you see our products also used in Jabal Al Omar, and this is also a fascinating project which we had the pleasure of working with. In Dubai, if you pass by, we have done some interesting high-rise projects. This is the Skyview Towers. This is Burj Vista. We have some interesting project where all the architects are based, is the Dubai Design District, where all the top architects have the offices and hosting the Technal facade. Right, so that is a quick introduction of what Technal does and how Technal is positioned in the region. And now it gives me the opportunity to segue into the main topic which we have come here today for. So we want to talk about what are the key functional parameters which one should take into consideration while choosing the window, door, and facade. Now, in the Middle East, we are known to adopt the latest technologies. And a great example is mobile phones. You know, ever since the 80s, whatever mobile phone was launched, the Middle Eastern people, including all the expats living here, they're the first to upgrade to technology. In fact, there was a report which says that we have 99% of social media penetration, which means we have the latest devices with our phones. And as a new phone launches, I think the first market to adopt that is the Middle East. But unfortunately, when it comes to specifications for facade, right from the 80s till now, we are always following the same principle that the facade or aluminum window and door must have profiles with 3 mm wall thickness. And this has not changed ever since 80s till now. Many of the projects, many of the consultants still believe that a thick profile or a thick frame means a strong frame. And hopefully the objective of today's session is to break this myth and hopefully give you better parameters to look forward to whilst choosing the facade and not just the wall thickness. So what does a facade skin do? What are the real objectives of the facade? So first, of course, you want to design the facade in a way to reduce all the negative external factors. You have heat, noise, damp, storms, rain, cold, sun. So you have all these negative factors which you want to protect your facade from. On the contrary, you want to also use the facade to maximize some of these energy available around you. So you want to let in the natural light inside your building as much as possible. You want to let ventilation, and especially during this COVID pandemic time, it's proven that the more ventilation you have in your building, the more you're able to clean and cleanse the building with fresh air and negate all the unclean energy, unclean air which you have thanks to the air conditioning and so on. And we also want to use the facade positively with the sun which is available. So we want to use the sun in a very positive way on the facade. And most importantly, your facade is the first thing which you see on a building. This is the probably the most important thing, which people always say, the first impression is the best impression. So whatever your facade is designed, this is the first thing you see on the building. So you always want to create a striking impression from the first view of the building itself. So that's why the facade skin is quite important. So what are the parameters which you should look for? The real parameters which you look for. And I've shortlisted 10 of the most important critical factors which we look forward to. The first thing is ventilation, because your facade has the opportunity to let your building to breathe. The second factor which you should look for is thermal insulation, because this is directly related to the energy efficiency of your building. Air, water tightness, and structural stability, a very important factor as well. Safety of the building, which is again a very critical aspect. And all these elements should allow you to give you the architectural freedom to design the facade as per your design intent. Also, we should look at sustainability, because today we all understand that buildings have a great opportunity to contribute to sustainability factors like the embodied energy of the materials used in your building. Solar energy production, your facade today is a great amount of area which is available, an opportunity for you to generate energy thanks to new technologies and advancements in technologies around BIPV. Automation is something which is interesting parameter to consider, because today you are so digitally connected and your whole world is surrounding around digital tools. Automation of facade also will have a great impact in the future. Digitalization, I mean, using technology to help reduce the stress during the design process. Technologies such as BIM, which have come and helped to develop and enhance the design process, is also very, very important. Solar control, sun shading elements, which also help in reducing the solar heat gain coefficients of your building. So you have 10 interesting parameters as a base consideration for choosing the right facade system. Out of these, I have classified the ones on the left are good to have, right? These are really good technologies, good parameters to consider. But on the right, these factors like ventilation, thermal insulation, air tightness, water tightness, structural stability, safety, architectural freedom, these are must-have and non-compromisable. These are parameters which you should not compromise at all. You should always have these parameters considered while choosing your facade system. In the Middle Eastern context, the most important parameters as a baseline parameters we should consider are wind loads, water tightness, air permeability, thermal insulation, acoustic insulation, fire and life safety. Now, I'm really happy to say that the new SPC, the Saudi Building Codes of 2018, are really fantastic, because they have really detailed and given a very broad perspective and guidance for some of these topics. And that is something which I will try to showcase along my presentation, the relevance and connection to the new Saudi Building Code. So today, as architects and designers, not only do you have these factors which are important, but you also have some baseline government guidance which helps you to make sure your specifications are more broader and more tighter in the context of performance of the skin, the facade skin. Let's talk about wind loads. So the wind loads essentially are your structural integrity of the whole facade, window and door. Now, here we have something which is quite interesting and important, because the facade and fenestration product which you choose must be considered for the wind loads which the building will experience in that particular area. Now, just having a wall thickness of 3 mm does not mean it is suitable to adapt to the winds or the different wind factors which come and impact your building. So how do you do that? So there are some considerations we do. Firstly, when a building is designed, the building has what we call as a wind tunnel report, which gives you a facade cladding pressure study, which kind of indicates to you what are the kind of wind pressure the building is exposed to. and this is also has a factor of the buildings around it. A building surrounded by high-rise buildings could also experience a very different wind pressure thanks to vortex effects if the building is located in such an area. Local building codes also help to kind of determine what should be the wind pressure to consider for a particular building. In the Middle East, we usually consider as a guideline the American code, which is the ASCE 07, in the absence of such wind tunnel studies and cladding pressure data. Now I'm showing you a nice, interesting video, which in 2019, it was a very small, low-rise building in Odisha, which is in the eastern cities of India. And we had experienced a cyclone called Cyclone Fani. So watch how this cyclone passing through the building really impacts the whole facade and the windows and doors which are there in this particular building. So the cyclone just rips through the facade, rips through the glass, and just throws away the facade right outside. And this is a building which has been experiencing such high wind pressure on that particular day, almost up to 2.2 kPa of wind pressure. And the wind pressure also in terms of wind speed, it was almost to the tune of 200 km per hour. That's the kind of wind this particular building exposed to. So how do we design products to kind of tackle such kinds of wind pressure? So at Technal, what we do is we do our testing for our doors, windows, and facade to what is called as a destruction wind pressure. So here, for example, this slider, which we have, it's a sliding door. We are testing the sliding door for a destruction wind pressure of 6.2 kPa, which is 2.21 times the strength of the Cyclone Fani, which you just witnessed in my previous slide. So my colleague now is shouting out the wind pressure. It's at 5.3 kPa. You can see how the window is bulging with all the wind hitting it. Now it's 5,500, it's 5.5 kPa. It's 5.8 kPa now, the pressure inside this particular chamber. Now the 6.2 kPa, and you see at this particular time, it is completely reaches maximum and the window is thrown and fallen. So the door which Technal manufactures is tested for up to 6.2 kPa of safety load, which is 2 times the Cyclone Fani. Now, what is important also is that we have to understand the anchorages is very important, the quality of fabrication is important, the choice of system is very important for such kind of high requirements of wind pressure and so on. For most high-rise buildings, the wind pressure commonly noticed is about 3 kPa. That means a safety load of 1.5 times is recommended as per the code. So 4.5 kPa is generally the kind of wind pressure you need to test your product for destruction. So safety is something which we can never compromise. So you have to look into this factor of wind loads and how the products are tested, not only for design wind pressure, but also for the safety. You have to check what are the worst case scenarios your building can be experiencing. So although this Cyclone Fani was hitting a low-rise area, the building was hardly 10 floors and not even taller than that. But the wind was extreme that day, and it reached, almost 2.2 kPa, 2.2 kPa on that day. So your products need to be tested for the most extreme scenarios, and that's what is very important. One of the very important criteria to choose as well when choosing the facade system. Now, linking this to the Saudi Building Code, I'm really excited that the Saudi Building Code talks in detail about the wind speeds which are in different zones in Saudi Arabia. As you see here, the central provinces of KSA are experiencing almost 52 meter per second 3-second gust speeds, and on the coast you see there are about 42, 44. So you see the wind speed is differing from zone to zone, so we cannot say one product fits for all territories. So it's very important. For example, if you're developing something along the Red Sea, the basic wind speed we are considering in the Red Sea is about 46 meter per second, which is equivalent to 165 km/h wind speed. So you have to define the product selection based on the zone where you are selecting. And I'm really excited and I'm proud the Saudi Building Code talks about these wind speeds along different portions of different pockets of Saudi Arabia. So this is something to look forward to, the wind speed and the structural loads which your facade experiences. The second factor which we have to look at is your water tightness, because this is really a factor which is helping you to weatherproof your buildings. There are various standards available today for testing. You have the EN standard or the ASTM standard. The water tightness requirement could range anywhere between 300 to 600 Pascal, depending upon the building requirements. But the CWCT guidelines call that a minimum of 20% of the design wind pressure should be considered as minimum water tightness. For example, if your building is experiencing 3 kPa of wind pressure, 20% of that, which is 600 Pascal, should be your minimum water tightness of your facade or window or door which you're putting on that building. Now, if the wind pressure is above, design wind pressure is above 2.4 kPa, the code says you should have a minimum of 25%. So the code also pushes the barrier a little bit higher when you have wind pressures really above that particular format. Now, in water tightness, how do you test it? On the right-hand side, you see the image of a video of how we test our products too. We test for static and dynamic conditions. So right now we're showing how we test our facade in dynamic condition. And the rule is that when you're applying this wind and also water, there should be no water visible on the inside. So I'll show you both the videos. First, now on the left-hand side, you will notice how the real Bombardier engine light is used to measure the dynamic water tightness. And as the propeller starts, you have water being sprayed along all these racks of water spray, and there is simulating a rain effect. And on the right hand side, you see we are noticing from inside if there is any kind of water leakage or we're seeing if any kind of water present or available to be seen inside. If there is water inside, that means your system is failing. So by doing these tests, we are simulating a real life rain condition to test and challenge your facade. And that's a very important factor to consider when you design your building and choosing the right facade, windows and doors. So what happens if you have a leaky window? Now this is a picture of a very famous picture which is floating on the internet, where the resident has to use all their clothes to stop water from entering inside during a rainy day. You know, there are several pockets of Saudi Arabia which is exposed to rain, a lot of rain, and it is important that we are protecting our windows. And the factor and criteria which we look for is to have a tested window for static and dynamic conditions, and static water tightness at least as a bare minimum. The picture below is a bit of an exaggeration, but of course what we try to mean is that we spend millions and sometimes in some cases excessive amount of money for the interiors of our building, because we are looking at that space as really a space to live, to invite people in. But imagine if you have a leaky window, you are exposing all that wonderful furniture and wonderful elements which you have purchased, and all of them is exposed to terrible risk if water starts to leak in. So please do consider this criteria, a very important criteria, which is your water tightness. The third important thing, and this is a very famous issue which happens in the Middle East, is air leakage. And if you have a leaky window in terms of air permeability, if there's excess air infiltration, what happens is, like the picture on the right, you start seeing dust and sand, especially during a very strong sandstorm day. So air tightness requirements, again, usually are a range between 150 to 300 Pascal, with different leakage rates prescribed for different kinds of product formats. So a sliding door versus a hinge door versus a fixed curtain wall, all of them have different types of leakage rates, but the pressure always varies either from 75, 150 up to 300 Pascal. What happens when you have a leaky facade? Air leakage means excess exfiltration of air. That means more hot air is coming inside, so it is pushing you to have more and more air conditioning. Sometimes during windy days, you start hearing whistling noise. The dust entry inside is really impacting the indoor air quality. There is a high chance of condensation risk because you are having extreme heat outside and you have excessive AC inside. So obviously there is a huge potential of humidity. Therefore, you also have condensation risk. You have definitely increased internal temperature, which again boggles down to having more and more air conditioning used. So what happens when this humidity happens? After a period of time, you start seeing condensation appearing on the inside of your windows and doors and facade. Now, when you have excess condensation, you have many issues. When you have a lot of condensation happening on your facade, there is a huge potential for mold growth. There's poor indoor air quality, which I'll explain to you in the coming slide. The surface starts to stain. Your surfaces start to corrode, as you see here in this image below. Your internal finishes start to deteriorate, and of course, all your insulation systems inside your building starts to break. And whenever you have dry walls, for example, in hotels and in hospitals, we use a lot of dry walls. And when these dry walls are exposed to condensation, thanks to this humidity, molds start to form. These are invisible killers, which we don't see, and it really impacts the indoor air quality and therefore affects our health completely. Once again, the Saudi Building Code comes here and really defines in the new code very distinctly the air leakage rates. And they've really specified that for curtain walls, what should be the air leakage rates, for skylights, what should be the air leakage rates, and for all of the products, they've really mentioned what should be the air leakage rates which are acceptable. And they've also mentioned at what pressures they have to be tested. So once again, the Saudi Building Code really pushes the bar up and starts to make note of these problems which has happened before and is now getting widely being used in the industry for all the new upcoming projects. The fourth criteria, which I would like to talk about, is thermal insulation. Now, thermal insulation is again connected to the facade system or the window and door system. The old market was all about having curvy design, was all about having to deal with heavy amount of fabrication, thick sections, which I talked about earlier, the 3 mm wall thicknesses, sturdy, big, bulky profiles. That was really what the old market trends were. But the new market trends, the new language which architects speak are technology. Architects and designers want to know about sustainability. Architects are today talking about the total ownership cost. They're not talking about the initial investment, but hey, if I upgrade to this technology, what is going to be my payback time? And most importantly, they're talking about user-centric design and comfort. All of this is related to the energy efficiency of the building facade. Now, we did a survey and we found that in the city of Paris, you see here, the city is so densely populated that the microclimate of the city is constantly evolving. Now, in this, we have shown two graphs, and when you see the blue line depicts the microclimate in the city of Paris when all the air conditionings are switched on. So when you have air conditioning switch on, there is a lot of heat which is dissipated into the air, and therefore the temperature is at a very high level within that densely populated city. We found that when the AC was switched off for just one day, the microclimate along the cities dropped by 1 degree Celsius. And that's a tremendous impact on the microclimate of your buildings and your cities. So this is a very important factor that when we use more and more air conditioning, it means that we are constantly increasing the microclimate of our cities. And when this reaches a certain level, it is creating harmful impact to the environment. So the old vision for a window and door and curtain wall in our region especially was all about having these cold systems, which is non-thermally broken systems, and these systems are bulky, they're thick, and it was all about robustness, which is what people cared about. But today, with the advancement in technology and the evolution of design, we now have a qualitative jump to what we call as thermally broken systems. So this is a very important leap because, as I explained explained in the earlier slide, by having energy efficient systems to have a less impact on the cooling loads, you are really promoting the and conserving the microclimate of densely populated cities. So what we are using in our current thermally broken systems in Technal is we have what we call as a thermal barrier. So this is a lovely image which depicts the benefit of thermal break. So you have the profile, which is two child profiles are crimped together with this material called polyamide. And this acts as a thermal break between the two profiles. So as you see here, when you're keeping this in an environment of minus 100 degrees Celsius, your internal frame does not get all that impact which you see from this image very clearly, simply because the conductivity of the polyamide is far lesser than the conductivity of aluminum. So we are able to break the heat flow. So in the cold countries like Europe, you have products only duty, or the facade's only responsibility is to keep the cold away from the outside so that the heating loads inside the building are less. But in our Middle East context, it's quite the opposite. We want the heat to stay away so that our consumption of AC is lower and lower. So really our role is to ensure that we have quality amount of energy saving in air conditioning. So with the use of the Technal thermally broken systems, we have simulated and we've done several studies to prove that 40 to 80% of energy saving is possible by using thermally broken Technal systems. So also this also have a very positive environmental impact because these polyamide profiles are 100% recyclable, they're reusable, they reduce the CO2 emissions, as I mentioned below, because more air conditioning you use, you're stressing more on electricity. And you know, in the Middle East, not only do we have CO2 emissions, but all the energy is coming from oil. So we are literally burning oil to produce energy. And this energy is sold in subsidized rates to many of the projects so that the people can enjoy this unlimited supply of energy. But each time we are consuming more and more air conditioning, we're putting so much more stress in our oil industry because you're burning oil to achieve this kind of energy for us. By using thermally broken systems, you're reducing condensation through windows. So that's something which we saw on the earlier slides. The benefit of having less condensation is really needed for better comfort for people inside. If you're designing buildings with LEED rating, for example, use of this kind of thermally efficient facade systems helps you to gain more points. And one very important benefit by using thermally broken systems from Technal, you also get higher acoustic insulation, and this I think is something very important and covers in my next slide as well. By using thermally broken systems, you're able to achieve better sound attenuation. So this is how the technology has developed, and the building codes have also evolved. So from the 1950s, where a non-thermally broken profile, single glazed glass, was having around 5.84 system U value, which is assembly U value as we call it. It is a combination of profile and glass. Now we have upgraded in the Middle East to DGU, which is the double glazed glass, and we've also grown in the 80s for glass with low-E coating, hard coating, and in the 90s there was low-E with soft coating, and in 2000s there was development of argon fill glass that helped the U value to reach 1.36, and in the late 2000s we started to use warm edge spacer along with the glass. We were able to achieve an assembly U value of 1.36, and today in 2020 you are able to achieve U values of more than 0.93. Remember, lower the U value, lower the thermal conductivity. So you have seen over the years the technology has grown, and today we are able to offer assembly values of more than 0.93. So you can go even lesser than 0.93 in certain cases. But where is the industry standing today in the Middle East? In the Middle East, especially in Dubai, we are still along this 2.1 category. So we're still following the 1980 standard. But what I would like to insist here is that today we have technology which can give you better thermal performance, which means better energy efficiency. So what does the code say? And I'm again extremely happy that the building codes have defined what should be the assembly U values, which means the combination of profile and glass. So they have two factors, and this is what I've mentioned as two important keywords. One is what we call as a window wall ratio. So when the glazing is less than 40%, if the glass to wall ratio is less than 40%, the code allows you to take about 2.89 as a frame assembly U value, which is a frame and glass put together. But let's look at window wall ratios more than 50%. I think the code is very strong and very nicely put across that the assembly U value should be 1.87, which if I go back to the earlier slide, it is really an upgrade to what the local codes in other markets like UAE, for example, are prescribing. So it is really an upgrade in terms of when it comes to facades. The Saudi building codes are already talking about two factors. One is the window wall ratio, and second is they clearly specify the assembly U value. So as an architect, you should now look at not only the value of the glass, but also as the assembly U value, which means the frame and glass put together. Now comes the next important framework to consider, which is the acoustic insulation. Now, what is acoustic? And this is a topic which many people have a lot of confusion on, especially because to define what should be the real acoustic requirement for your building. So generally, acoustic values are prescribed by a specialist. There are consultants who are acoustic consultants who review the location of the building. Like the image here shows where the building is located, next to the airport, next to a metro station. Is it next to the sea, next to highly construction prone area? So all these factors are studied by a acoustic specialist, and then he prescribes that the building should have so and so acoustic values. So how do you read acoustic values? Is essentially the factor which we follow is RW, which is basically weighted reduction of sound. Now, this takes into consideration, really the RW talks about the acoustic quality of a window. So if somebody says my window is 40 dB, has a performance of 40 dB RW versus a window which is 35 dB RW, the 40 dB RW has better performance from an acoustic point of view. So in a basic terminology, in addition to RW, we have to also look at something called correction factors, which we call it as C and CTR. Now, C correction factors are basically factors which are, the traditional correction factors which we consider, and the CTR is correction factors related to traffic. So we have two of these important criteria which we add. So what is very important to notice is most of the architects, they look for the acoustic performance of the glass and they consider that as the final acoustic performance. But really, like the thermal performance, the acoustic performance also is an assembly value. You need to consider the framing around it as well. So the RW of the glass is not necessarily the RW of the facade system. So you need to have the entire assembly value calculated. And Technal has already pioneered in the sense that we have our own acoustic simulation software and we have our own acoustic lab where we simulate different kinds of glasses with different kind of framing. And we now have a library of data to share with consultants and architects on what each product with each glass combination can offer in terms of acoustic quality. So in layman's term, if somebody gives you a value of RWCCTR as 41 minus 2 minus 5, it means that for low to medium frequencies, which is generally the traffic noise, your performance is 41 minus 5, which is 36 dB. So under extreme traffic, the correction factor of minus 5 is added to that 41, you achieve 36. In high frequencies, you talk about what we call as a ping performance, is when you use that C value. So when you have 41 and you have a C value of minus 2, the weighted performance is 39 dB for high frequency noise. So this is basically a thumb rule way of calculating and assessing the acoustic quality of a window. So in terms of product, Technal has various categories. So when you look at the most basic product, which is a non-thermally broken, as we call it, as a cold system, you have RW values of 34 dB, so weighted reduction of 34 dB. And then we have an upgrade. So now we have a qualitative leap. We're using thermally broken systems. So when you have products like Solial and Lumial, which are thermally insulated, you have an improvement in the acoustic performance up to 35 dB. And further enhancement has been done in products like Galeen, which is your lift and slide door, where you can go up to 40 dB weighted reduction. And by inserting these foams, you see here these yellow foams, these foams can further enhance the dampening and can further enhance mass to your hollow sections and can improve the acoustic performance up to 42 dB. Please note that these two profiles are thermally broken. So you saw earlier in my slide that thermally broken profiles systems not only improve the thermal performance, but also contribute effectively in the acoustic performance as well. The last one, which is very important, is perimeter fire protection. So when you have a facade, you are always having a zone which is called the zone of invisible, we call the zone of invisible accountability, because this is the area of the facade on the screen, on the curtain wall, and then there's your slab, and there is a potential risk of fire jumping from floor to floor. So the UAE Fire and Life Safety has got a very well-defined code, and that prescribes a facade system to be tested as an assembly for 1364 Part 4, which is the standard, a go-to reference standard for perimeter fire protection. And we have done a lot of collaborative study with SideRise, where we have promoted the knowledge quotient of this particular topic within stakeholders in the region by doing tests which is prescribed by civil defense. So we have done tests where we are able to achieve more than 3 hours of integrity and insulation fire protection across the spandrel edges. We will talk more about fire on the day when we take the fire and life safety course, but this is an important component which I thought I should bring up to you when you are choosing the right facade system. Of course, there are other parameters. So you talk about blast proof, bulletproof, burglar resistance, sustainability, user-centric design. These are good to have parameters to have with you for sure. But definitely stay tuned for these courses, because we're going to be talking more about them in the coming days along this week in the Facade Design Week with ArchiNet. So I would like to conclude just to bring you back into perspective. What are things we discussed today? Number one, remember the evolution of the mobile phone. The mobile phones have evolved. We have curved screen phones now. We have dual screen phones today. The specification and the technology surrounding the windows doors have also evolved. So please ignore the 3 mm wall thickness. Today we talked several factors from air tightness, water tightness, structural stability, thermal performance, acoustic performance, fire performance. So you have all these factors to consider before choosing the facade, and not just the wall thickness of the profile. And these are other parameters. In addition to these, we talked about the good to have ones like solar control, digitalization, automation, solar energy production, sustainability, and environment. These are good parameters to have too. So stay tuned for the next few days where we're going to talk about these good to have parameters as well. Most important, we have a fantastic new Saudi building code, and I think this code will be truly successful if we as an industry start to implement it. I thank ArchiNet to give us this opportunity to talk about this, because we would like all the architects to start prescribing, revisiting the specification documents and aligning them to the new Saudi building code, because this is when we can really elevate the quality of construction in our region and in our markets. And last but not the least, don't forget thermal insulation. We talked about so important, especially in cities, in urbanized environments in Saudi, where buildings are getting rapidly developed. Please think about the microclimate around these cities. We as architects and consultants and designers have a huge responsibility to upgrading the technology for our facade windows, doors, and facade systems. So that brings us a wrap to today's session. I hope you enjoyed our conversation. And at this time, I would like to bring back Mohammed, and hopefully, if there's any questions, we can take it up as well.
Yes, Arvind. Okay, so today talk is done. We asked everyone to prepare their questions during the talk, so they can share it now. Meanwhile, we have the test questions that we have in the pools. As you can see, everyone in the bottom of the screen, we have beside the participant and between the chat, there is a pulse. So we have these questions that we will run. Arvind, do you want us to start the questions now or after the technical?
Let's do that. No, let's do that.
Okay, so
let's open up the polls and I'll put the questions on the screen. Yeah, so here we go.
Before
this.
Okay.
Yeah.
Yeah, we need everyone just to make sure they are focused with us now, so we can start the question and answers. Arvind, these are questions, right?
Yes, these are questions, so you can pull up the poll as well. So the same questions.
So we'll start with the first question. Now, the poll actually having 5 questions. You will have a window that pop up on your screen now, and it's having. We will wait about 5 minutes to answer all the questions, okay? Okay, the questions should be up now.
Question, yeah, I will read it out to you. Which of the below is not an important functional parameter for choosing the windows, doors, and facade? Is it air tightness, water tightness, wall thickness of aluminum, or structural stability? Which of the below is not an important functional parameter for choosing the window, door, and facade? So you're open to answer that?
Yeah, they can answer first question first. Yep. Please, everyone, answer the first question. We have 177 people and one only answered. 2. Okay.
Oh, now it's coming up.
Yeah,
yes.
5. No, maybe it was lagging. Okay, sorry. No, now it's jumping. Okay.
Remember, only if you answer the question, you will get your certificates.
Okay, this is from Technal, not from ArchiNet.
So we have 17 responses and people have started to answer the second question as well. Yeah, and yes. I can also read the second question if you would like.
Please go ahead.
Poor airtight and watertight windows. What do they lead to? Condensation, dust entry, water ingress during rain, or all of the above?
Okay, everyone, the questions should be in the pools. الأسئلة يا جماعة اللي منتبه لها، الأسئلة موجودة تحت في خانة التصويت اللي هي بين الشات والبارتيسيبنتس في البار اللي موجود تحت اللي فيه شير سكرين والسكيورتي. فالجميع مطلوب يجاوب على الأسئلة. We have more 2 minutes and a half. Do you want to read the third question, Arvind?
Yeah, sure. So I'll open the third and fourth question.
Yes.
Okay, so today you can have facade thermal performances up to 3 watts per meter square Kelvin, 2.1 watts per meter square Kelvin, 1.9, or better than 0.93 watts per meter square Kelvin. So these are 4 options on thermal performances. And the fourth question, in terms of facade acoustics, more the RW, the weighted reduction factor, more the RW, better is the acoustic performance, true or false? So these are the questions number 3 and 4.
Arvind, the third question is really scary, but anyhow.
Actually, it was in my slide. So this is
Okay.
an important question on checking the whether I was able to communicate better. So more is a test for me.
Okay, just to let everyone rest assured that even if your question's answer wasn't correct, it doesn't mean that you are not getting the
Absolutely,
attendance
yes.
certificate.
You still get the
It means,
certificate.
yes.
Yes,
Yes.
absolutely, Mohammed, absolutely spot on. And I'll read my fifth question, which should be a no-brainer. It should be easy,
No.
and I hope
Not now.
and I hope everybody gets this right. The Technal brand is originally from France, Germany, UAE, or KSA. I hope everybody gets this one at least correct.
No. The people who answers KSA, please don't give them certificate.
Absolutely. Oh, I see some people replied KSA.
Yeah.
God.
Okay. Okay, so we will, please, if you can rush answering the questions, it's only we have about half minute because we will close the chatting, the questions, and we will go to the questions from attendees. We will give you more 15 seconds to answer, everyone. Arvind, we will give them more 1 minute, okay?
Perfect, sure. So whilst they are attending these questions, I'm just going to show you my last slide. Your feedback is really important for us. So if you're done with your polling, please make note of this link, which is flashing on the screen. Please give us your feedback on today's session. It's very important for us. And when you are filling this form, your name and email would come to us. So we would be able to also issue the certificate, irrespective of the poll answers. So yes, please make note of this survey link. There is a QR code also flashing on the screen. If you just point your camera on that, you will get the link. But if you want to make note of the link, this is also available. We can also put this on the chat box if it's required to make it easy. Maybe Mohammed, if you could help us put the
yes, I already put it.
Oh,
so
fantastic.
Once you complete the poll, you need to go to this link and fill the information to generate your attendance certificate. And plus that, this is the link again, just in case. We are 80%, 84% answered. So we will give you another 30 minutes maximum, then we will end the questions. So if anyone wants to answer the poll, please do it now, because this will be connected with the survey and receiving your attendance.
And then we have our last slide. Of course, these are our contact details. Myself, Arvind, and my colleague Khaled, we are open for any questions. Feel free to reach us. Again, there's a QR code. If you scan that, our contacts will come straight onto your phone. So feel free to reach us if you have any questions, any inquiries. We are more than happy to assist you.
Okay.
So
I finished the questions now. The poll is over.
So the first answer, if I may quickly,
please, can you go to the slide so we tell everyone what was the question?
Okay. So the first question: which of the below is not an important functional parameter for choosing the windows, doors, and facade? The correct answer is wall thickness. So wall thickness is not the functional parameter for choosing windows. We talked about this as the most important ones: air tightness, water tightness, structural stability. And I'm super proud that 80% of you got that correct. So congratulations. That's a very good effort. The next one is poor airtight and watertight windows lead to condensation, dust entry, water ingress, or all of the above. And the correct answer is all of the above. And once again, fantastic. 94% of you got it correct. That's brilliant. Super. You're a very good audience today. I'm really proud of all of you guys. Well done. Third question. Today you can have facade thermal performances up to 3 watts per meter square Kelvin, 2.1, 1.9, or up to 0.93 or better, and the right answer is up to 0.93 or better. And again, 70% of you got that correct. Fantastic. Kudos. The fourth question, in terms of facade acoustic, more the RW, better is the acoustic performance. This is true, and 79% have got this correct. So fantastic. And the last question, and this is a very big question for me. Technal brand is originally from France is the correct answer. So 72% have got that correct. So for those who said Germany, yes, we have a German brand called Vicona and under Hydro. UAE, yes, we have an office in UAE. KSA, yes, we have presence in KSA, but the right answer, the brand is originally from France. So majority of you have got the right answer. So that clearly shows the quality of the audience. You've been a fantastic audience. Thank you so much for being with us and listening patiently to our session. So
now we have the questions. Yeah. So keep the presentation up.
Yep.
And would you please open your camera?
Yes, I will.
Okay. So we will go with the first question now we have received. Anyone who sent earlier questions, please resend it again, because we had many people asking about the pools, so we will get lost your question. So this question from Abdul Manam: what is the required solar heat gain coefficient for non-residential buildings as per Saudi building code for glass and a simple panel overall aluminium frame and glass? What is the percentage of glass?
Very good question. So again, the code clearly talks about the solar heat gain coefficient. I'll just go back to the slide. Yes. So you have, depending upon the location. So we have what I've on my screen is for any window less than 40%. So your residential falls under less than 40%. So the solar heat gain coefficient is maximum allowed is 0.25. So this is your as per prescribed by the code. I hope that answers.
Second question, just a second through, because we had plenty of other questions here. Okay, this is a question from Abrar. Why having air tightness is different from having water tightness? Wouldn't the physical barrier, wouldn't the physical barriers that prevent air would logically prevent water?
Brilliant question. So what happens when there is water hitting your window or door facade? The water actually goes through your frame and the water needs to come out. So there is something what we call as pressure equalization which happens. So that needs to be defined in the system design and detailing. Whilst the air infiltration talks about allowing air from outside inside, water has a different behavior altogether when it hits the facade. So your water tightness is all about evacuating water in a very calculated format outside so that water doesn't come inside. So water should not gush inside. So imagine a sliding door, you have a frame and a shutter. So there are a lot of loose areas between the frame and the shutter. So water can potentially come inside because of the pressure, which in a rainy situation, given a rainy situation, you have a lot of pressure and the water starts to push in. So with natural pressure equalization, water should be able to drain out at certain pressures. So that is why, whilst airtightness, a strong airtight window not necessarily mean a strong watertight window. And usually in when you enhance the water tightness in windows, you're creating a lot of holes, slot holes for the water to drain out. If you have a lot of holes, a lot of air can also infiltrate. So it's a very nice balance between air tightness and water tightness. So it is essentially important to take both into consideration. I hope that answers the question.
Okay, Arvind, regarding the U value that you mentioned, can you mention what is the standard reference for it? Not the Saudi reference.
In Saudi Arabia, there is no local standard per se. We always follow NFRC, which is very relevant to the local condition, which is NFRC is National Fenestration Rating Council. So that is part from the American standard. Then we also have the European norms. We have the EN standards, which talks about European conditions. So we have both. We have NFRC and we have European. So we are free to choose from both. But in the local context, the Saudi context, we follow NFRC, which is more the American standard.
Okay, we have another question from Abdul Manan. What is the required solar heat coefficient? I think we answered this question, sorry.
Yeah.
This question from Rania. What is your take on green facade and what are the parameters involved in this framework? I think this will come in coming talks, right?
Yes, stay tuned for the last day. If we're going to talk about sustainability, we will keep the suspense for Thursday.
Okay, so we have some questions up. I need to scroll up a little bit because some people were trying to share the answers on the public. They thought so they thought the chat is open. We will not let you. So, okay. This question from Rahaf. Could you illustrate where the high thermal conductivity is used and the low thermal conductivity in the frames?
If I understand you well, where do you need a low thermal conductivity and where do you need high thermal? So when you have areas exposed to excessive heat, right? For example, central Riyadh, for example, is a very very heat-prone zone compared to probably places close to the Red Sea, and also I've been seeing some nice hill resorts close to Mecca. These kind of areas where there is generally a cold weather, and if the average weather across the year is about 26 to 32 degrees Celsius, you can do away with little higher thermal transmittance values. But if you look at zones like central Riyadh or places like Jeddah, Dammam, you still are exposed to an average temperature of 40 to 50 degrees in a year. So it's highly important to note where your environment is, where you're building, where your project is. If the project is exposed, for example, in India, we're using it's acceptable for higher thermal transmittance values because India is a tropical country and the average temperatures don't go beyond 32 degrees Celsius. So when you have AC inside at 24 and 32, you are still maintaining the dew points. But in Middle East, you have conditions like 40 and above, and then you have AC blasting at 20 degrees. So you need to have a good amount of thermally efficient window facade to ensure that no condensation happens.
Okay, we still have a couple of questions. This question from Tarek. It's related, who's your presence or representative in Saudi Arabia? So they can contact them. They have plenty of projects. If you can share your contact detail, please, if you go to the last page, because a couple of people asking for your contact. This is Arvind and Khalid contact details. You can contact them for any questions related to
absolutely, and we will guide you to our
we have a couple of other questions related to our topic today. Let's okay, so this is from Noor. Her question is having heat island effect produced from glazing when used reflective glass. It comes in handy to reflect heat, but at the same time, it affects the environment. How can we achieve both sustainability around the building and to get less amount of heat penetration inside?
Very, very good question, and I'm glad that you brought this up. Today, the microclimate, and this is what we talked about, the heat island effect, is a very important factor. One is from the building air conditioning consumption, also the reflection of heat and glare because of excessive reflective glasses. One way to reduce it is today we have developed in partnership with our suppliers a new kind of coating, which is called cool coat. And with using this cool coating, you're able to have a very low albedo effect compared to a normal coating on the facade or on the windows. So by using this cool coating technology, we are able to greatly reduce the heat island effect cost by the frame at least. Whilst we don't have a lot of control on the glass, I think by using these cool coating technology, our friends in Jotun and Axonobel, they developed this cool coating technology, and they have proved that they've reduced the albedo effect greatly. So for example, a standard black would have a very high albedo effect because it absorbs a lot of heat, but the coating with the cool coat, you have far lesser albedo effect compared to your generally black colors. So that is one way to do it. And another way to reduce this is by having a good amount of natural shading. So by having a lot of shading devices incorporated in the facade, you greatly reduce these kind of urban heat island effects. So these could be two strategies which you could work on. And of course, if you have less reflective glass, this will also help.
Okay, we still have 7 questions to go. Please, I want to answer all the questions.
Sure.
We have a question from Jamal. Is there any modern technology to prevent any dust to get in the buildings?
To prevent dust, I mean, airtight facade is one. Definitely. Proper cleaning, regular maintenance of the facade is another one. But naturally, we can't control nature. I mean, that's all, that's from God. So we don't have any tools to control dust, especially in our region. But we can always have good strategies to make sure that the dust doesn't reach inside our buildings.
The system that you have is preventing it to what percentage?
So it depends. So we have different systems. For example, we have a system called a lift and slide door, which is working on a gasket compression system, which can offer you up to 600 Pascal resistance for air infiltration, compared to a normal slider, which would offer only 300 Pascal. So you have 100% better efficiency in air tightness by simply upgrading on normal sliding system to a lift and slide system.
Yeah. Okay. So there's another question from Sabri. Do we expect a link? Oh yeah, he's asking about the talk. The slides. Plenty of people asking about the slide that you shared with us. Is it possible to share it with attendance?
Sure. Please send us an email either to Khalid or to me, and we would be happy to send you a more compressed version of the presentation.
For today only.
For today only, yes.
Yes. Okay. So next question from Noor. What are the best requirements for vertical residential housing units?
Oh, sorry?
Residential housing units.
Residential housing, right. So the most important factors, as I told in the presentation, make sure that the windows are thermally broken and at least meeting to the code requirements, very important. Air tightness, water tightness, very, very important. The structural will not be an issue because I'm assuming these are low-rise residential compounds, but very important factors would be air tightness, water tightness, and your thermal efficiency. These three are very, very important for the long-term operational costs of the building. And if it's exposed to heavy wind or if it's close to the sea, then please consider the structural requirements as well.
Okay. So another question, what is the shading coefficient meaning?
Right. So shading coefficient essentially talks about one is, as we talked about the U value, which is the thermal transmittance. The glass allows certain amount of natural shading depending upon the coating. So it is directly linked to the amount of light which can come inside your building without leaving a huge amount of transparency. So if I have to answer in a layman's term, it talks all about the natural shading which the glass can provide without compromising on transparency and allowing the light inside. So it's a combination of these three factors: light, transparency, shading, the natural shading, and really the look and feel of how the glass looks like.
So this question from Ziad: glazing processors doesn't provide warranty for spacer with argon gas, or what basis Technal is providing relevant to U values?
So just to clarify, we don't make glass, we don't produce glass. This is an expertise and a domain which glass suppliers do. So usually the warranty comes, the glass performance warranty comes from the glass suppliers. As Technal, we are taking the glass U values as an input from the glass processors or the glass suppliers, and we then put it onto our formulas and our software, and we simulate the thermal performance. So essentially, we are committing to the thermal performance of the frame for sure, and with respect to the glass, it lies in the responsibility of the glass supplier.
Okay, so this question from Ahmed. How could you isolate the windows systems or curtains with the wall or whatever the surface with the 0.5 millimeter around the surface? Is this done with sealant or what kind of the material, and is that affecting on the isolate efficiency? Thank you.
Right. So, as I understand from your question, we're talking about the fixation of the sliding frame onto your masonry wall.
Yeah, I think he's mentioning the gap between the glass.
The gap between, yes. Yeah. So definitely we have a specific standard. So once the primer is put on the wall, we have certain EPDM material which helps in preventing any kind of leakage. But in several scenarios, when it comes to windows and doors, we're using weather sealant to close the gap between the frame and the masonry wall.
Okay, this question from Muhammad. After Beirut blast, most of the fenestration were totally destroyed. This raised a debate in choosing a blast-resistant fenestration versus blast-proof. Can you elaborate more the difference?
See, there is nothing called blast-proof. If you want blast-proof, you need to put steel walls, you know. But when it comes to rating a product, we're always talking about blast resistant. Resistant to what? Resistant to certain amount of blast load at a certain distance from where the blast is originating from. So this is what we are always talking about, blast resistant facade or blast resistant glazing. Yes, it's an important topic, but what happened in Lebanon was a very unfortunate event. Nobody predicted it. Nobody predicted that this would happen. Where we use blast resistant facade is for highly diplomatic areas. For example, you're talking about embassies, highly secure areas for VVIPs. In those areas, how we define the blast resistant glazing, first of all, this will be talked more on the next session, but just to give you a quick answer to your question, at all these VIP zones, there is always a zone where security checks are happening, you know, and this is the point where the person who wants to detonate the blast can be present. So it is from that zone till the distance where the facade is, that is the distance we are measuring, and the blast load. So the security analysts and the security consultants, they always come and give us this value. Okay, my project needs glazing to resist a blast of, let's say, 100 kg of TNT at a distance of 25 meters. So they give us these values, and based on these values, we develop the system required to resist that kind of blast in an unfortunate event if that happens. So
okay, I'm still receiving questions, but we need, I will try to pick the most important repeated ones. So because we already 30 minutes, about 30 minutes ahead from the talk. So we have question from Ziyad. Is the double skin facade efficient enough to be adopted in commercial buildings? When should be the money back?
Very good question. This is exactly coming on the last day, but yes, and the answer is yes. Double skin facade. Yes, it is very energy efficient. Yes.
Okay, this is Osama. The global climate changes. The summer getting hotter and the winter getting colder year after year. Does the code consider these changes?
Does the code consider the changes?
Yeah, does the codes, building codes, does it change with along with?
I mean, this is a tough question for me to answer because these are governed by
about the
little
topic,
bit far from my experience and expertise. So I would stay away from this. But I'm very proud of the new Saudi building code. I think this, hats off to them. They've taken a lot of pain and effort to bring this up. Yes.
So this is another question from Milland. While designing the system, which risk factors are considered?
I trying to understand risk factors.
What are the risk factors that you take in consideration during designing the wall system, let's say?
So when as Technal, we design system, as I mentioned, we take 3 years to develop one system before it comes to the market. So the first thing which we definitely design the system for is to be future proof. So we have to make sure that the system which we design lasts for at least 10 years in terms of the local environmental conditions. We have to design from a metal builder point of view, the customer who actually fabricates the window. It should be easy for him to fabricate. It should be easy for them to install. We look at architectural trends. Every year we invite architects to join our survey, and we understand from them what are their requirements, what are their lookouts. And last but not the least, the product needs to be locally available and commercially viable. So these are factors which we look at when we design a system. So we just don't bring any system designed in France to Saudi Arabia, but rather we take into all this consideration and factors, and then we bring it to our markets.
Okay, so key questions are done, but we have to mention something because a couple of people are sending their emails. If you want to get a copy of the presentation from Mr. Arvin, please contact the email that you can see now on the screen, arvin.kumar@hydro.com, or Mr. Khalid.hinadi@hydro.com. You can send them, or you can screenshot the screen now and scan the code, the barcode, to get the email. Regarding the video of the this design talk of the week, we will upload it after a month from its completion, next Thursday. So in October, inshallah, it will be online. So thank you, everyone. Thank you, Arvin and Khalid, for being with us tonight. Tomorrow we will be back in the same time, and hopefully it will not be having tough questions like today. Thank you.
Brilliant. Thank you again, guys, for your time. Thank you, Mohammed, for organizing and inviting us for this wonderful opportunity. We look forward to tomorrow and looking forward to more interactions tomorrow as well. Good night and have a wonderful evening ahead of you.
Bye-bye. Bye-bye.
Bye-bye.